Hi. Today we would like to see this coding problem of longest substring without repeating characters or no duplication. That is, this is the given string that this ABC, AB, CBB. So we need to find a substring out of this such that that substring should be longest string out of the possible ways, and that shouldn't contain any repeating characters. So for this, ABC is the longest string that is possible with these conditions. Okay, so how to solve this problem? So this being a like string problem, so one of the approaches is we will iterate through this string, and will store the each character in a hash map. Of course, if it is a repeated character, it will be updated. But before updating, we need to check if the existing length. I mean, we need to store a start index, like the start index for the possible string. We will initially make the start index at 0 initially, and we need to update the start index based on the condition, like, okay, like start index is equal to maximum of, or the start index already existing one, or the newly got start index, like last seen start index for a char plus one. What this means is, so if you encounter a new character again, so in that case this will be executed, and initially, which I told, that the start index which was pointed to the initial 0 will be updated here. So will be updated to B. Why? Because we need to consider a string that actually don't contain the repeating characters. So if you point here, this won't be this can't be considered um, as a single string for our reason, for our problem. And also we will create a hash table and this string start index. Apart from that, we need to just check the lengths every time. Okay, if already a is present, if you get the string length string a new substring as ab, just okay, we will just check the lengths. If the new string has bigger length, just update it with the length. Just one thing to state here is we won't use the actual substrings, we will use the indexes. Okay, so this will be executing in a time. I will still keep this. Okay, so I will so this will be executed in a time complexity of big O of n. We will just need to iterate through this string, and creating a hash table. Hash table time complexity is the minimum number of the characters in the hash table, mean the length of the hash table, or the length of the string, right? So if a two a's are present, and in the hash table only one a will be captured, and if that is the case, so the space complexity is of big O of n into m. M is the length of the hash table. Okay, regarding that is the time and space complexities. Now we will manually see what happens regarding the logic. Okay, so we have created the hash table like this, and okay, the iteration started from starting character. Is a present in this hash table? No. So then update the a in this with the index which that element is presented. So a is equal to 0. So we will just make a list, or I mean just store the character of that. This won't be executed until we have encountered a character which is already present in the hash table. Okay, so we go further, and we have seen the b. So we will update this. Is b is not present, so we have to create inside the hash table with its index. Okay, so we will consider this AB. So AB is AB length greater than the already existing A? Yeah, absolutely. So update the AB, which is of a larger length. That's what longer substring is what needed in the problem. So go further. C. C is not present, so update it with this with its index. The ABC is larger than the existing one, so update here. Okay, so the interesting thing next here is A. Okay, so A is already existing here. So first thing what we will check is if already existing character is seen, the first thing we'll be executing is this start index. So start index is equal to maximum of the already old start index, which is 0, plus last seen of the character. So we have seen this A here as new character again. So what is the last seen character value here? A is equal to 0. 0 plus 1. So 0 plus 1 is 1. So what does this start index 1 means? We are see we have got the A again, and we have seen again. So we are trying to move remove this A and start our new possible or potential substring after that A. So we in this we are just removing that uh, just character and moving our starting index of the new substring next to that. So it will be updated to 1, which we got from here. And we will check that. We will check. This is the new start index, right? So we will check is BC greater than the ABC? Is BC length greater than ABC? No, definitely no. So we won't update here. But but before moving further, we need to we are currently at this index, right? So okay, so we will update. We have seen this BC, so we are checking at this I is equal to 3 iteration. Now I is equal to 3, then we processed this, right? So then we came here and we have checked the length from start index to just plus 1, I plus 1. Okay, this is less. So I is equal to 3. I is equal to 3 now, and we need to update the new index of the character here as 3 here instead of 0. Okay, so we have updated that and go further. Is B already present here? Yes. If it is already present element, then the start index will be executed first. So what is the start index? We have got the start index as 1 here, and the last seen character B is present at 1. So 1 plus 1 is 1 plus 1 is 2. 1 plus 1 of the maximum is 2. So initially update the start index as 2. Start index as 2. We are just removing the that B character which is repeated again. And C, when CA is less than CA is greater than the already existing possible larger substring. It's not equal. We have got ABC. So this won't be updated here. Okay. So but before moving further, we need to update this B index from 1 to 4. Okay. So we need to consider the CAB. 2 we have considered the CA. We need to consider the CAB. So is that length equal or greater than? It's we need to just check the greater than. So CAB, is it larger? It's equal. So we won't be updating this. Okay, so go further from B to C. Here we got the C again. C again. So we need to update the starting index. So start index we will update as the initial start, the current start index as 2, and the last scene start index of C is 2, excuse me, is 2 plus 1, which is 3, which is 3. So just update the start index to 3. Okay, now again we need to check from here AB. So is AB is AB greater than the already existing ABC? No. So we so no, but we need to, before going further, we need to update the C index as 5 here instead of 2. Okay. So we go to the next element. So we got ABC here, ABC, and we are currently at this iteration I is equal to 6. So this is again a repeated character. So we you need to update the, this will be executed, and this will be executed. The current index is 3. The last seen character for B is 5. 5 plus 1 is 6. The 6 is bigger. So start the index with, yeah, so start the index with 6. Start index is. Okay. We have got BB here. BB. So did we, is it larger than the already existing ABC? No. But before further going, you need to just update this B character to B character to 6. Okay, so we go further. BB is less, so that's it. So it ends. Okay, so how will we implement this in code? So finally we got the ABC, which is the answer ABC here. Okay, so definition is longest substring, longest substring with non-repeating characters. It will take the string as input, and initially it will create a indexes. So it will create a variable longest is equal to, I will take 0 comma 1. Why, what's this 0 comma 1? So this means string of 0 is to 1. So this is what I mean, 0 1. So what will this give? String of 0 1 will give a, the first character, only the first character. The 1 will be eliminated and it won't be considered. Okay, so this is what I'm trying to, I am just working on the indexes rather than the actual strings. Okay, so we initialize the uh, longest indexes to 0 1, and okay, so we need to iterate, or we need to create here just this. I will call this as last scene, the last scene hash map, hash table. So last scene, I will create a hash table. Okay, so I need to update when we iterate. So start the iteration for I, for character directly y indexes. So just character, for character in the given string, for character in given string, what we need to check initially, we need to check if that character is already present in the, if character in already is present in the last scene hash map, what will happen? This need to be executed. Make the start index start index is equal to maximum of already existing start index or so the last scene the last scene of char plus 1. So initially, so we need to just put start index as 0 here, initialize that. Okay, we can run this. Okay, while iterating, okay, if the character is not present mm, in the hash table, so what we will do, if the character is not present, we need to make some code like we need to initially check this length, right? Isn't it? So if the longest uh, if the longest of I the longest of I minus longest of 0, what is this longest of I'm just trying to check this condition, check the length. If the already existing length is less than, so less than last seen, less than, we okay, we want the indexes to, so we need to enumerate here. We can just get the I here, and this will be I, and the first one, when we enumerate, the first one would be the mm, index, and the second one would be the value. So enumerate on the, what we need to do on the string, given input string. So when we enumerate it, so we have got this I, this is the already existing length. We need to make that as I plus 1 minus, what is the initial starting index? Starting index is the start index, just that, which we started with 0. What is this I plus 1? I plus 1 is, say for example, we are calculating the I. So we need to add I plus 1, because mm, so similarly as I told before, I 1 is 1 doesn't get included here in calculating the string. Say for example, we have character A, B, C. If you want to call this using just these two parts with indexes 0, 1, 2, you will call it as 0 is to 0 is to 2. So 2, the second index element is not included uh, in this call. So in this slice, so only 0 and 1 would be there. So in that is the reason I have kept, instead of I plus 1 minus start index. Start index is, we are updating the start index such that the substring will start from. Okay, so longest of 1 minus longest of 0 less than I plus 1. If this is larger, so what we need to do, we need to update this longest indexes. The longest indexes, we will just update this as just these values. The first one will become start index as a new start index, and second index will become I plus 1. Okay, so we have updated this. We have checked the length, and we need to see the last scene character. We need to update here too, right? So the last scene for that specific character you update it as a new I that we have seen at that new ith index. So I think this is the logic here. We just need to return. So we are just calculating the indexes. So we need to pass this as where as a substring. So call the substring with two indexes. That is the longest of 0 is to longest of 1, the new updated indexes. So this will give the what we are doing, this will give the maximum longest substring, because we are calculating the length and updating the indexes. That will give the longest substring. And we are we are removing the already appeared characters by updating the start index. In the new substrings, we are not going to take anything which we have seen already characters. So this will make that, and we are just returning the string substring. I think so. Regarding the time and space complexities, this will run in the time complexity of big O of n, where n is the length of the string, and space complexity of big O of, as I told, minimum of the string, which is of length n, or something like x, where x is the unique characters or length of the hash table. So the last scene. Uh, so I think we are calculating this longest, created this last scene, enumerating the string start index. Yeah, we are updating that character in the character and its index here. So this would be on the same line as this. I think this completes. That's it.